Seems good. I'm gonna just show you what they look like, and then I'll show you what we're actually gonna be doing. Okay, so this is not notes from last class. There we go. Let me just go over what we did, and then we'll talk about something new. Okay, so last class we went over exponential functions, the letter E, which we said was just a number, and we said that number was equal to 2.718. So whenever you see letter E, that's all that means. Okay. Then we introduced this idea of the logarithm, and to do this, what I'm going to do is we're going to work on a warm-up real quick, just to get the idea of a logarithm kind of set in our head, and then we'll continue on with these notes. So instead of going over the notes from last time to give us an idea of what is going on here, I'm actually going to flip over to the logarithm page. Okay, and we're just going to talk about how we find logarithms and what in the world they are. Okay, so just a little bit of a review. Remember, we had this thing called exponential form. Okay, and let me write out an example of this. So 7 to the third power equals 343. Okay, and I called this exponential power or exponential form. Okay, and the reason it's called that is because we have an exponent, and it's very widely used, right? Okay. Now, before we go and try to write the logarithmic form, I'm just going to label a few of the values here. Remember, we called whatever number on the bottom is called the base of the exponent, right? So this is the base. The thing up top is always called the exponent, which I'm sure we all know that's true. And then finally, I didn't really have a term for the final number, but I called it the final answer, right? Final answer. Okay. Next, this question is asking us to write this in logarithmic form. Logarithmic. Oh my God. Okay. Is there anyone who can tell me how I could write this in logarithmic form? Perfect. Log base 7 of 343 equals 3. Okay, so logarithmic form isn't really doing anything to anything. We're just kind of rearranging the numbers so it says it in a different form or in a different order, right? Now the base still comes first, but it's like on the bottom of the logarithm. Our final answer comes second. And we're saying it's equal to the exponent. Okay, so essentially what logarithms are doing is it's asking the question, what power should I raise 7 to get the final answer of 343? Okay, it's basically kind of the inverse of an exponent, right? Instead of finding what the exponent equals, we're going backwards and trying to find the exponent. Okay, let's do some practice finding logarithms, and then we'll continue on. Okay, I'll do the first one, and then I'll let you do the other ones. Okay, so our first one says to find log base 7 of 2401. Remember, the way I like to do this was, I was like, okay, I want to know what this logarithm equals. So it's equal to question mark, right? The next thing I did is I rewrote it in exponential form, right? So instead of writing this, well, I'm going to take the base first, which is 7. I know that my exponent is the last one in my log, so the question mark is my exponent now. And I know that this equals 2401. So essentially, I am asking myself, what power do I raise 7 to get the final answer of 2401? Okay. Any ideas of what this number might be? 4. And how did you go about finding it? Oh. Nice. That's pretty good. Okay, if you didn't have that option on your calculator, which is fine, what I would do, the way I would get 4 is I would do, okay, what's 7 to the first power? Do that in my calculator and get 7. Well, that's not 2401. I would do 7 squared and get 49, and I'd be like, that's not 2401. I do 7 cubed in my calculator, and that gives me 343. And that doesn't work. And then finally, if you do 7 to the 4th power, you should get 2401. And you're like, okay, finally, that's the answer I want. So I know my answer is 4. Okay, so it's more like a guess and check to figure out what the answer is. Okay. Any questions on this first one? All right. There's a couple tricky ones in this list here. I'm going to give you a few minutes to work on this. You can either work together, or if you would like to work alone, that's fine too. But I'm going to give you a few minutes to do this, and I'll be walking around to see if you're on the right. So when you have a negative 1 power, it actually means
oh, you mean like contraction. Okay. I was thinking the bottom of the fraction.
All right, let's come to the front here. So really good job as I've been walking around. Looks like we're all on the right track with at least thinking about what logarithms are. I know finding them is a little bit hard to think about conceptually, at least to me. That's not very intuitive to me. I remember when I was in algebra, I didn't like logarithms very much, but regardless, we started off with a log base 5 of 25, right? So this one's very similar to what I did here. Will, you wrote this one up, right? Do you want to take us through your steps? Mm-hmm. Perfect. So the answer to this logarithm is 2. Any questions on regular logarithms? All right, let's get a little bit crazier here. Okay, we have the log base 25 of 5. Who wrote this one up? Was it Marissa? Do you want to take us through this one?
So I rewrote it into an exponential form. A fraction is what makes it a smaller number. So I realized that the square root of 25 is 5. So then I knew it was 5.
Perfect, right? So I do want to kind of expand on what Marissa just said. Marissa said she took the square root of 25. There's no square roots written up here. So why did she say the square root?
For which one?
For this one.
Oh, because if you square root 25, you get 5.
Perfect, but why didn't she write a square root? And why is that?
Okay, I'm not sure.
Because what's this anything to the 1/2 power? What is that actually saying? It's the square root, right? So Marissa didn't have to write the square root symbol because anything to the 1/2 power is a square root, okay? So I know it looks weird with the 1/2 in the exponent. If you would like to, you can just start square rooting, third rooting, fourth rooting. I know the square root of 25 is 5. And another way of saying that is 25 to the 1/2 equals 5. Okay, so either one works, but the one that's probably most helpful for us for the logarithm is when the 1/2 is in the power, because that's the answer to our question. Okay. Any questions on this one? All right, moving on. Next we have a log base 2 of 1/2. So now we have a decimal inside our logarithm. Who wrote this one up? I think Yaz wrote this one up. All right, I'm gonna go through this one real quick. So what Yaz did is she rewrote her question in exponential form. And instead of writing 0.5, she wrote 1/2. Okay. Now, the reason she did this, I think, is because it's easier to think in fractions when we're doing logarithms. I'm explaining your problem, yes.
What was that?
I'm explaining your question, but it's okay. You're fine. Okay. And then what Yaz did is she started plugging in numbers, trying to see what power of 2 equals 1/2. Okay. Now, a big hint in this question is we went from a whole number to a fraction. Okay, whenever we do that, that's a big hint in our heads that we need to plug in a negative number for our exponent. Okay, so 2 to the negative first. Why is 2 to the negative first equal to 1/2? What do we do with negative exponents? Flip it, right? When we have a negative in the exponent, it means flip the 2 to the bottom. Okay, so remember, change the sign, you flip the line, right? Okay, so that's why this is true. Okay, and because we found the exponent that we can raise 2 to get half, we know the answer is -1. Any questions on that one? All right. Next we have log base 5 of 125. Again, we have a fraction in our logarithm, which is a hint that the answer should probably be negative. Who wrote this one up? Oh wait, then who wrote up the last one? It's a great mystery. No idea who wrote that one up. Weird. Okay. All right. So Yas, do you want to take us through this one?
Well, I knew that 5 to the third was 125. This was a fraction, and then it had to be negative. So I plugged 5 to the negative third into my calculator and gave me a decimal, but then I put it into like a math fraction, which gave me 1 over 125. So I put that to the next one.
Perfect. And I like how Yas said, okay, I know that 5 cubed is 125. Okay, and that means that 5 to the negative 3 would be the inverse of that, or 1 over that. Okay, so that's a good way to figure out what it is if the fraction isn't just like 1 over that number or anything like that. Any question on this one? All right, finally, we have log base 8 of 2, which is a little bit more tricky than the things I've asked you before. Who wrote this one up? Allison, do you want to take us through this one?
So, I know the cube root of 8 is 2. So, and the 2 is lower than 8, so it has to be a fraction. So,
Perfect. Allison was like, okay, 2 is lower than 8. And the thing inside the logarithm isn't a fraction like these ones. So that means I know the answer has to be some sort of fraction. Now, instead of writing 8 to the 1/3 equals 2, 8 to the 1/3 is literally the cube root of 8. Anytime we have a fraction in the exponent, it means a fraction exponent. Okay, so because in your calculator you can do the cube root of 8 or the 4th root of 8 or the 5th root of 8, and because we did the cube root and got 2, we know our answer is 1/3. Any questions on any of these logarithms? Perfect. Okay, I think we're pretty warmed up on logarithms. We know what these are. We're actually going to pick up with our notes from last time. And I think I saw people walking in. Is there anyone who needs these? All right, so we did a bunch of logs last time. And now I kind of want to tell you why logarithms and exponentials are grouped together in the same packet, the same section in the textbook, and why we even talked about inverses at all. Okay. Now remember, when I introduced the idea of an inverse function, we said we could switch x's and y's, and even before I told you to do that, I told you that inverse functions are things that we've worked with all throughout our lives, right? Even in kindergarten, we've dealt with inverse functions, we just haven't called it that, okay? For example, plus and minus, and multiplication and division, right? Those are things that cancel each other out, that you can do on both sides of an equation to undo the other. Oh yeah, another example of an inverse function would be the cubed root and x cubed, right? Things that undo each other, okay? Well, we talked about logs, we talked about exponents, and it's kind of easy to see how these two are inverses because they're basically opposites of each other, okay? And well, since they're mutual inverses, they do undo each other just like multiplication and division do, okay? Now, I just kind of want to go through a few of these examples. Now, a random log and a random exponent aren't inverses necessarily, okay? The way that they're inverses is if the bases are the same. So in this example, we have log base 3. It's not the inverse of any exponential function. It's actually the inverse of 3 to the x. So as long as the bases match each other, they're inverses, okay? Now, more generally, log base a of x, so a is a number like 2 or 4 or something like that, that's going to be the inverse of a to the x. Okay. Then the same thing goes along with even weirder logs, like log base, I don't know, 10, 105,000 is the inverse of 105,000 to the x power. Now, the last one's a little interesting. We introduced the natural log, which is like 2.713 to the x power, is the inverse of log base e of x, which we'll have a name for later on, but we'll get to that. Okay. So because we know this information, we know that they undo each other, we can actually use this information to solve equations using logarithms, okay? And I'll show you this in a weird way here, okay? In this example, we have an equation including logarithms here. And it says 3 to the x over 2 plus 1 equals 10. Before I even do this equation, I know that this is a logarithm question and an exponential function because the x is in the exponent. Okay, so that's my hint that I know that's the type of question I'm working on. Okay. Now looking at this, it looks like the hardest part of the question is the exponent, right? That looks like it's making the question hard. Let's put that on one side of the equation and put everything else on the other side of the equation. Okay. What I mean by that is subtracting 1 on both sides. Okay. If I do that, I'm going to get 3 to the x over 2 equals 9. Now, this is really nice because now my hard part is on one side of the equation. The easy part is on the other side of the equation. Okay. I have a exponential going on here. Any ideas on how we can undo this exponent? We could put it in log form, but there's actually like an x over 2 in the exponent, which is going to make it a little bit hard. What undoes 3 to a power of something? I think I heard you say it. Not the square root. Look at what we have here. We have inverses that undo each other, like squares in the square root or multiplication and division. What do you think is the inverse of 3 to a power? It's right here. Log base 3, right? The opposite of 3 to a power is log base 3 of that number. Okay, I'm going to do something really weird, and you might think it's confusing right now, but I promise you once you get used to doing this notation, it's fine. Just like taking the square root of both sides, or squaring both sides, or subtracting something from both sides, I'm going to take log base 3 of both sides. Okay, so I'm going to have 3 to the x over 2 on one side, 9 on the other. I'm going to take the log base 3 of both of the numbers. Okay. Does that make sense? Okay, on the left, we have log base 3 of 3 to the x over 2. Any ideas on what that would produce? Any ideas on how to simplify this? We haven't done it yet, so I don't expect you to know it, but any ideas?
Somehow the log 3 and the log 3x cancel each other out.
Yeah, right. So since we have, yeah, okay, that's a good guess. And that's basically what we're doing. So nice job there. Log base 3 and 3 actually cancel each other out. okay? Just like division and multiplication cancel each other out, or squares and square roots cancel each other out. Now I know we're canceling out an entire word like a log, but that's kind of how this goes, okay? Now Yaz was like, okay, I don't know what to do with the 2. This is what happens, okay? Anything in the exponent just stays the same. So this becomes x over 2. Okay? The log 3 and the 3 go away. So we're left with just the exponent on the left. And on the right, I'm not going to touch it. So we have log base 3 of 9. Okay. Now, I actually think we can figure out what log base 3 of 9 is. In some questions, you're not going to be able to figure out what it is, but I think in this case we can. Okay, so on the side here, how can I write log base 3 of 9 in a way that helps me solve it? So I want to find log base 3 of 9. Yeah, 3 to the what equals 9? Well, what power of 3 equals 9? 2. Good. Okay, so another way of saying log base 3 of 9 is 2. Okay, so x over 2 equals 2. Are we good so far? Good. Okay, once we're here, I'm just going to rewrite this equation so we have space to do it. We have x over 2 equals 2. Okay, how do you think I should get x by itself? Multiply by 2, right? So times 2 on both sides. And I'm going to get x equals 4. So we can easily solve equations, including logarithms and exponentials, this way. Okay. Any questions on this one? Sounds good. You know what? I think I'm going to do this next example with you. Maybe. I don't know. Okay, I'll do this example with you in front of the class. We'll do more practice next class. Okay. Going down to example number 10, very similar question. We want to solve 2a to the x over 3 equals 11. Okay. Now, the hardest part of this question is a to a power. So maybe I should get that a to a power by itself. How can I get the a by itself, or the a to a power? Good, divide by 2 on both sides. Okay, if we do that, we're left with a to the x over 3 equals 11 over 2. Now I have the logarithm, or sorry, the exponential by itself. What should I do on both sides to undo a to a power? Good, log base a, right? Log base a of both sides will undo the exponent, okay? So we have log base a of ax to the third, or x over 3, and we have log base a of 11 on the right. Okay.
Hold on, what happened to the 2?
Oh, the 2, oh, sorry. Sorry about that. Thanks, Steven. That makes it a little bit nicer, right? Okay. What cancels out here? Good, the log base a and the a cancel each other out. So on the left, I'm left with x over 3. And on the right, I'm left with log base a of 11 over 2. Okay, now this is an example of something that I can't really find the final answer of. If I try to do this by writing it in exponential form, I don't know what a is, so there's no way I can find the exponent I raised a to get 11 over 2, okay? So in this case, since the bottom of the log is just a, I'm not going to figure out what this is, okay? So I'm just going to leave it alone. Okay, but x isn't by itself yet. How can I get x by itself? Multiply by 3, right? So 3 on both sides gives me x equals 3 log base a of 11 over 2. And we kind of just leave it like that. Can't figure out what that log is, so just gonna leave it alone.
So is that right? That's 3 log A, or is it 3 times log A?
I would say, if I were to say this, I would say 3 either times or just 3 log base A of 11 over 2. That's what I would say. Mhm. All right, any questions on example 10? All right, now the quiz is a little bit long, so what I'm gonna do is I actually wanna start the quiz now, if that's all right with you.